Good day, everyone. Now, seniors, let's answer the remaining questions on the examples we are treating on direct and inverse variation. The question says, we are to continue from question 16. It says, m varies directly as the square of n. M varies directly as the square of n. So I go straight and jot that down in symbols. M varies directly as the square of n. The question then says, if n increases by 10%, can you see that clearly? If n increases by 10%, find the percentage change in m. Okay? So m varies directly as the square of n. We change it to an equation, it will become m is equal to kn squared. Now the first value of m will be k times n1 squared. So another value of n, m2, when n changes, will be k times n2 squared. In that case, n will have changed from n1 to what? n2, increasing by 10%. So we go straight and say m2 is equal to what? m2 is equal to k times n2 squared. Now, what is the relationship between n2 and n1? You can see n increases by 10%. So the ratio of the new n to the original n will be 100 plus 10 over 100. When something increases by 10%, this is the ratio of the new one to the old one, or to the original one. Now, n2 over n1 will now be 110 over 100. n2 over n1 will be 110 over 100. So if you simplify this correctly, you will get n2 over n1. You will get n2 over n1 is equal to 1.1. You will get n2 over n1 is equal to 1.1 over 1. Now, cross multiplying, what will cross multiplying give us? Cross multiplying will give us n2 is equal to 1.1 n1. Can you see that? An expression of n2 in terms of n1 will be n2 is equal to 1.1 n1. So in this place where we have m2 is equal to k times m2, in this place where we have m2 is equal to k times n2 squared, I'm going to go ahead and put 1.1 n1 where I have n2. So that means m2 will now be equal to k times 1.1 n1 all squared. So if we simplify that, what do we get? When we simplify that, we'll get m2 is k times 1.1 n1 times 1.1 n1. That gives us k times what? 1.1. Remove the numbers out, times 1.1, then times n1 times n1. That's going to give us m2 is k times 1.21 n1 squared. So that means m2 is equal to what? That means m2 is equal to 1.21 times kn1 squared. But you will remember that this expression 1.21, you remember that this expression kn1 squared is the same thing as n1. So in this place where we have m2 is equal to 1.21 times kn1 squared, in this place where we have m2 is equal to 1.21 times kn1 squared, that means m2 will be what? 1.21 times m1, because this expression represents m1. m1 is k times n1 squared. We saw that here. m1 is what? K times n1 squared. So the value of m2 will be the same thing as 1.21 times n1. You understand? m2 will be 1.21 times m1. So we have our answer now, halfway. Change in m is equal to m2 minus m1. That gives what? 1.21 m1, because m2 is 1.21 m1. So change in m will be 1.21 m1 minus 1 m1. So if you factorize m1 outside the bracket, m1 is the same thing as 1 m1. If you factorize m1 outside the bracket, you get 1.21 minus 1 inside the bracket times m1 outside. So that means the change in m is 0.21 of the original value. So percentage change in m is now going to be change in m1. Percentage change in m will now be change in m over m times 100%. That gives us what? That gives us 0.21 m1 over m1 times 100%, and that will give us 21%. So since this is positive, 21% is the same thing as plus 21%. So since this is positive, that means when n increases by 10%, m will increase by 21%. It's as simple as that. Let's go to question 17. It says the illumination of a light is inversely proportional to the distance from that light. So I will be equal to what? K over D. This is inverse proportionality. So if you change it to an equation, I will be equal to K over D. It says the illumination is 10 units at a distance of 4 meters from the source of light. So what do we get here? 10 is equal to K over D. We substitute what's it called? We replace I and D with what? 10 and 4 respectively. So 10 is equal to K over 4. 10 over 1, introduce 1 here, will be equal to K over 4. Cross multiplying will give you K is equal to what? 40. Now, the relationship between I and D will now be I is equal to 40 over what? Over D. So now that we have the value of K, just come here and replace that value of K with what? 40. Just come here and replace K with 40. You get the relationship between I and D. The question now says we should find I when D is 20. First thing is to write our relationship out. I is 40 over D. So I will be what? 40 over D 20. So I is 2 when D is what? 20. Question 18 says Q varies directly as R squared. That will change to what? Q is equal to K times R squared. The question now says, I always like to indicate where we changed the variation from an expression of variation to an equation like this. The question now says, when R decreases by 20%, what is the change? What is the percentage change? If R decreases by 20%, what is the percentage change in Q? That's simple. So if R decreases by 20%, that means the ratio of the new R over the first R will be 100 minus 20 over 100. That gives 80 over 100. And if you cross multiply, 80 over 100 is the same thing as 0.8. When you cross multiply, what do you get? You get R2 is 0.8 R1. You get R2 is 0.8 R1. So in this case now, from Q1, let's write Q1 as what? K times R1 squared. So Q2 also will be K times R2 squared. The new value of Q2 will be K times the new value of R squared. So going forward, what we do here is simple. Replace R2 here with what? 0.8 R1 all squared. That will change to Q2 is K. That will give us Q2 is K times 0.8 R1 times 0.8 R1. 0.8 times 0.8 will give us what? 0.64. R1 times R1 is what? R1 squared. So Q2 is 0.64 times KR1 squared. Rearranging, this will be 0.64 KR1 squared. So now look at this very well. KR1 squared, look at this very well. The value K times R1 squared is the same thing as Q1. The value K times R1 squared from here is the same thing as what? Q1. So we can replace Q1, we can replace K times R1 squared with what? Q1. So that Q2 is now equal to 0.64 times Q1. The change in Q will be the final minus the original. 0.64 Q1 minus 1 Q1. This is like 1 Q1. So if you factorize Q1 from both sides, you will get Q1 outside the bracket. You get Q1 outside the bracket, and what do you get? 0.64 minus 1, which is minus 0.36 Q1, which is minus 0.36 inside the bracket. So that gives you Q, that gives you change in Q is minus 0.36 Q1. So the percentage change in Q will now be change in Q over original Q. Or we can say change in Q1 over Q1. You can write it as change in Q over Q2 if you like. So that gives us what? That gives us what? Minus 0.36 Q1 over Q1 times 100%. So this we cut this. You get minus 0.36. You get minus 0.36 times 100%, and that gives you minus 36%. This means when R decreases, by 20%, Q will decrease. Q decreases by 36%. Can you see that? Very simple question. So question 19 says L is directly proportional to T squared, and L is 64 when T is 4. You can look at the question itself. We now need to find L when T is 9. So L is equal to KT squared. 64. We use this set, L is 64 when T is 4, to find the value of K. We always use a complete set to find the value of our constant of proportionality, or constant of variation. So 64 is K times 4 squared now. 4 squared is 16, so 64 is 16K. 16K is 64. K is what? 4. After getting K as 4, that means L will be 4 times T squared. That's the relationship. That means the relationship between L and T is L is equal to 4T squared. Replace your constant now with the value you got for it, which is what? 4. Alright, let's move forward. We are to find L when T is 9 seconds. So using L is equal to 4T squared, L will be 4 times 9 squared. That's 144. 9 squared is 36. Take note. Number 20 says X varies inversely as P raised to power N. X varies inversely as what? P raised to power N. This is the same thing as X varies inversely as what? P raised to power N. The English will be S varies inversely as P raised to power N. So we write it like this. Then the question now says, okay, if X varies inversely as P raised to power N, it means X is equal to K over P raised to power N. We change it to an equation by introducing the K on the numerator side and changing the variation sign to equality sign. Now we have two sets of values to find our K. The first one says X is 4 when what? When P is 8. The second one says X is 16 when P is 2. So what do we do here? 4 is equal to K over 8 raised to power N. So we use the first set of values. 4 is equal to K over 8 raised to power N. Because we are told that X is 4 when P is 8. Okay? Then on the second side, we use this set to write an expression for the relationship between X and P. So X is 16 when P is 2. That means 16 is equal to K over 2 raised to power N. So for those two expressions, we now simplify. Introduce one here, and cross multiply. When you cross multiply, what do you get? When you cross multiply, what do you get? You get what? K is 4 times 8 raised to power N on that side. On this side, you get K is 16 Here you get k is 4 times raised to the power n. Here you get k is equal to 16 times 2 raised to the power n. So 4 is 2 raised to the power 2. And 8 is 2 raised to the power 3. So this will become 2 raised to the power 3n. So if you add indices, you get 2 raised to the power 2 plus 3n on the left here. Here, 16 is 2 raised to the power 4. So 2 raised to the power n is 2 raised to the power n. So k will be 2 raised to the power 4. So k is 2 raised to the power 4. So k will be 2 raised to the power 4 plus n. K is 2 raised to the power 4 plus n. So what does that give you? K on the value of the k on the left is the same as the k on the right, because we are referring to the same variation and the same equation. But we have two expressions for them, for the value of k for it. We have two expressions for it. So one is 2 raised to the power 2 plus 3n. The other is 2 raised to the power 4 plus n. So we equate these two. 2 plus 3n is equal to 4 plus n. So we equate 2 raised to the power 2 plus 3n to 2 raised to the power 4 plus n. Are you getting that? So bases will go out, powers will be the same. If these equations are the same, it means the powers too are the same. So 2 plus 3n is 4 plus n, 3n minus n is 4 minus 2, n is 1. After getting n is 1, we can use any of the expressions 2 raised to the power 2 plus 3n to get our k as 32 like this. Or we can use the second one, 2 raised to the power 4 plus n, 2 raised to the power 4 plus 1, n is 1, 2 raised to the power 5, 32. So k is 32. We can use any of the two expressions. You don't need to use the two in a test or an exam. Just use any one. That means the relationship between x and p is x is equal to what? X is equal to k over p raised to the power n. But now that we know the value of k as 32, I'm not going to write k, I'll write 32. Then p raised to the power n will become p raised to the power 1 because we got n as 1. So x is equal to 32 over p. That's our relationship between x and p. So that ends our examples on direct and joint variation. We'll be going to, that ends our examples on direct and inverse variation. We go to joint variation in our next class.